Hi everyone, this is Fisher Coder here. Today we're going through another very interesting and simple, straightforward question, which is getting asked a lot during real interviews, which is problem 1165, single row keyboard. Let's go through this question first. It's a hypothetical scenario, which is a special keyboard with all of the keys in a single row. It doesn't necessarily need to be exactly the same keyboard as you see, just align all three rows of characters into a single row. It could be in any random order, but that doesn't matter at all. So let's walk through this. Given a string keyboard, so the API signature is going to be one of the parameters is going to be called a keyboard, indicating only 26 characters or lowercase. That's the layout of the keyboard, which is indexed from 0 to 25. Initially, pay attention to this. Initially, your finger is at index 0. Very easy to understand. To type a character, you have to move your finger to the index of the desired character. For example, given this, let's walk through one example. Example 1. For example, given this in order alphabetical keyboard in one single row, all 26 characters in one line, A, B, C, D, E, F, G, up until Z. Initially, your finger is at index 0, which is at A. And then, so the given word, it's asking us, it's giving us two parameters in the API signature. The first one is the keyword. The second one is the desired target word. For example, for example 1, the target word is CBA. That means we want to type C first, followed by B. The last is A. As the explanation says, the index moves from 0 to 2 to write C, which means 0, 1, 2. That moves our finger from A to B to C. Then we got C. And then from C back to B, because the second character we would like to type out is B, right? Then we move from C to B. That means from index 2 to index 1. We moved 1. And the last character that we'd like to type out is A. Right now, our finger is at index B, which is at index 1, from 1 to 0, which is distance 1. That means the total time is going to take us to type this entire CBA string on this specially given keyboard is going to be 4. Very straightforward and easy to understand, right? A second example is kind of a random alphabetical keyboard, but it doesn't matter at all, as I said previously. The target word is LeetCode. So basically following the same logic, we'll just move our fingers from index 0, which is P in this case, to L. Where is L? It's all the way down here. And then move L, our finger, at index L to E, which is here. Then keep doing this until we hit the last character, which is E. There are some constraints given here. Keyboard length is only 26. That means there are only 26 lowercase English characters. The algorithm for this question is very straightforward as well. So we'll just start from the very first index, which is at index 0. Then we calculate the distance from the first character to the second character until the very last one. Every time we find the index of the second character, that means our finger is going to be moved over there. Then we'll start from there to calculate the new distance. And then we'll just sum up all of the distances, which is going to be our final answer. Well, then let's start coding. The algorithm is pretty simple. We don't even need any other fancy data structures. Only one for loop to go through this string array, which is the target word, is good enough. All right. First, we would like to have time. We'll call it time, which is the result that we are about to return, which means how much time is going to take for us to type out this target word character in this specially given keyboard. And then we need another variable called from index, which indicates where we are going to calculate the next character from, in the distance. Then we'll just loop through this word to char array. Every single character will need to take a look. And then we need another variable called finger moves. Let's call it finger moves. Basically, the distance that our finger needs to move from one point to another in order to type the second character. How do we calculate that? It is basically from index minus then we need to know the index of the second character that we are about to type, which is keyboard index of. In Java, we can use this built-in Java language API, which is called index of, which helps us to find the the index of the character C in this given string. However, it could be negative in a lot of cases, or in some of the cases. For example, in the very first case, from index, we set it to be 0, which means where our finger initially starts at, which is at 0. So 0 minus C, the first character of this example is C. So in this case, it's going to be 2. So 0 minus 2 is going to be negative 2. But we need a distance. Distance is always greater than or equal to 0. So we'll just use mathapps to take the absolute value out of this. And then at this moment, our finger is at C already, which is at, for example, in this example 1, which means our finger is at the from index is going to be at an index where the character C is, which is index 2 in this example. So keyboard index of C. And then how long does it take to type the second character? How much time did it add? That means finger moves. We'll just add that up. Then after iterating through all of that, we can simply return time. That's it. That's going to be the answer. Very simple and straightforward. Let's submit it. All right, accept it. Again, we'll go through this question again. So it's given us a special keyboard, and it's also giving us another keyword. It's asking us to calculate the time it's going to take in order to type every single character of this given string. The idea, the algorithm is very straightforward. Again, is just to loop through this entire given word by the index of the given specially designed keyboard. This is a very simple and straightforward question, and also a very simple, straightforward solution. But this is a very good question to help us get warmed up, especially during real interviews, to really help the interviewers to gauge your CS fundamentals, to help them to understand whether this candidate is a good one. Although it's super simple. Again, if you like this video, if you enjoyed it, please do me a favor and hit the thumbs up button. And do not forget to subscribe to our channel, and we'll keep publishing new videos. If you hit the thumbs up button, it's going to help with the YouTube algorithm a lot to help spread this video to a lot more audience. Let's ace through the interviews and get good offers in tech industry. Thank you very much. I'll see you guys next time.